Baa la njaa limekithiri si tu humu nchini hadi pia mataifa mengi ya Afrika na duniani, na utoshelevu wa chakula basi umekuwa ni donda ndugu. Watafiti wanakaa chini na kuangalia ni jinsi gani watahakikisha kwamba chakula kinazalishwa kwa wingi kutumia sayansi. Ndo maana watafiti, wanasayansi, maprofesa, wataalamu wa Chuo Kikuu cha Kenyatta wamekutanisha vichwa vyao katika maabara ili kuangazia kwamba swala la vyakula vya kisaki ama GMO linakuwa ni salama na pia kuna upatikanaji wa chakula. Ni Jumamosi nyingine marahaba, tunakutana katika kipindi Boresha Kilimo. Hiki ni kipindi ambacho kinaangazia nyanja mbalimbali za kilimo, teknolojia ibuka, hali kadhalika kilimo asili. Hii leo tunaangazia jinsi utafiti unatumika kuleta vyakula, kuhakikisha vyakula ni salama, hasa katika Chuo Kikuu cha Kenyatta. Popote ulipo, hujambo na karibu. Mimi ni Laban Shaban.
Kilimo ni nguzo kubwa kwa ujenzi wa taifa, kwani kilimo ndicho huboresha maisha. Ukitaka kujua haya usipime kipimo, na ukikaa nasi basi utaboresha kilimo.
Mabadiliko ya hali ya anga ama ukipenda mabadiliko ya tabia nchi yamekuwa tishio kubwa sana kwa utoshelevu na usalama wa chakula. Ni jinsi gani watafiti wanabuni njia tofauti ya kuzalisha mimea zaidi, na watafiti pia wanaangazia vipi GMO kuangalia usalama wake na pia njia ya kuzalisha vyakula ili kudhibiti baa la njaa. Utafiti ni jambo ambalo linaenziwa sasa katika kilimo, haswa leo hii kikitazamiwa kwamba masuala ya tissue culture, ambapo washikadau wengi wanafanya kazi kwa pamoja na matokeo yake ni ya aina 27 ili kusaidia wakulima kuzalisha zaidi matokeo.
Banana is a very important crop, not just in Kenya, but globally. It's a food crop, and it's also a source of income for the farmers. However, we have had challenges in production because of diseases and drought that have reduced the yields, causing losses for farmers. And we embarked on this project to try and overcome the challenges, the climate-induced challenges, of which diseases and pests have been shown to also increase with changing climatic conditions. So what we have done is that we undertook to write a project with partners from Spain, from Belgium, and from Uganda. And the idea was to work together as a consortium to introduce improved varieties. Now, the varieties we are working on are cooking banana varieties derived from matoke, the common matoke that is common in Uganda and also increasingly in Kenya. The varieties have been bred through conventional crossbreeding. And I would like to emphasize that these are not genetically modified. They have been crossed using natural hybridization, whereby the matoke, the preferred matoke, is crossed to an old variety of banana that has shown to contain genes for disease resistance. So we have come up with 27 new varieties of matoke, which have been shown to be resistant to disease and to also survive under drought conditions. So what we are doing here in Kenyatta University is to get those the improved matoke varieties, the 27 varieties, all of them. We import them from IITA in Ibadan, Nigeria. We multiply here in Kenyatta University in our tissue culture lab, and then we put them in this growth room. So when we import them, they're in this form, very small, some of them rooting, some without roots. So we put them through what we call the tissue culture process. And this is a process where you provide all the nutrients that plants need to grow. So you give them the carbohydrates, you give them vitamins, you give them source of sugar, you give them artificial light because they're not growing outside, and you allow them to grow. And once they go through the process and, after some time, maybe like 3 months, they form roots. So once they have formed the roots, we can now transfer them to soil. And we shall show you in the greenhouse how we do the transfer. So we take them, we put them in the greenhouse. The idea being, these plants, when they are in the artificial conditions, everything is provided. The environment is clean, there is light, there is food. So the plant just needs to sit there and grow. But once you take it to the field, you have to gradually harden it to be able to survive in the outside environment. So that's why we need to put them initially in a greenhouse before we take them to the field. We have been working in 3 counties, Embu, Murang'a, and Kenyatta. And we have used what we're calling a participatory gender-responsive approach. So the farmers have periodically visited the lab so that they can understand the process and so that they can own the process. So even when we are doing the evaluation, as we shall show you when we go to the farm, we involve the farmers so that they grow with the plant from the time we plant to the time of harvest. And we have realized that farmers are looking for different things.
Wafadhili wamechangia kwa kusaidia kuanzisha maabara ili kufanikisha utafiti.
We have 27 new varieties of cooking bananas. They are called Naritas after the breeders. They were bred through a collaboration between National Agricultural Research Organization, Uganda, and the International Institute of Tropical Agriculture. That's why they are called Naritas. So we did them as N1, N2, and 3, up to 27. But we also have plantains, also bred by IITA. So we were interested in the plantains because we don't have a lot of plantains in Kenya, and yet they have higher commercial value. So once we have rooted the plants in the lab, we usually put them in this chamber for 1 month to acclimatize them to the outside conditions, and then we pot them. We put them in sterile soil initially, and then in normal garden soil eventually. So what you can see here have been in this state. The bigger ones are 6 months old. The smaller ones are 2 months old. So the idea here is to ensure that they acclimatize to the normal environment, and once we feel they are strong enough, we can then take them to the farmers. So what we have done in the past is that we have now provided the farmers in Kirinyaga and in Meru with plants from this greenhouse.
Je, jinsia na kilimo zinahusiana vipi? Tutakuwa tunajua papa hapa katika kipindi hiki. Unaendelea kutazama Boresha Kilimo, kipindi ambacho tunaamini kitastawisha kilimo humu nchini. Kwa sasa nachukua pumziko fupi, na rejea na mengi zaidi. Usiondoke hapo ulipo.
Ukitaka kujua haya usipime kipimo, na ukikaa nasi basi utaboresha kilimo.
Utafiti katika kilimo na hasa utafiti wa migomba ama ndizi umeimarisha ni jinsi gani wakulima wataangalia kilimo chao ambacho kinaendelea, ili kuuliza wanasayansi wawaambie fanya hivi, twende hapa, ili tuimarishe kilimo chetu. Karibu katika sehemu ya pili ya kipindi Boresha Kilimo, ambapo tunaangazia vipi Chuo Kikuu cha Kenyatta kinafanya utafiti kuongeza utoshelevu wa chakula na pia kuhakikisha kwamba chakula ni salama kupitia njia za maabara na kufanya utafiti. Endapo una maoni, hisia, mapendekezo, maswali, ama wewe ni mkulima unataka sisi tukutembelee, tutafute kwenye mitandao ya kijamii @KUTV Kenya. Nifikie mimi @Laban Shaban. Weka reli Boresha Kilimo.
So at Kenyatta University, we have been doing a lot more research on different germplasm, together with colleagues in this university who have done very excellent work in GMO research. And our contribution a lot more is in terms of making sure that apart from the research that we do in the lab, that the public also gets to know and how that impacts on their lives. For instance, did you know the GMO debate right now is the hottest debate in the country, alongside others really. But as a university, we have a responsibility to sensitize the public and get to know what exactly is in this GMO. And that is why part of the researchers in this university, including myself, are right now actively sensitizing the public through media and going around into different universities to ensure that at least even professors themselves are not contradicting themselves in this matter GMO. It is one aspect of research that has attracted a lot more discussions, and everybody has all of a sudden become an expert. And like I was saying earlier on, this is the only university in East and Central Africa that has a biosafety level 2 laboratory. And because of that, we have also been very privileged that the government has been actually funding this GMO research. I know I've personally received 2 times the grants from National Research Fund. That time it was called NACOSTI, but now NRF, and again even NRF itself has funded me and colleagues in the lab to do GM stuff. I am aware of what my colleague Steve Runo is doing, and that is with the striga. Personally, I have been active in research that is seeking to make drought-tolerant maize. And how did we do this? We are looking for genes that can confer drought tolerance. And of particular interest here is the gene or our genes that we are picking from sources that are already tolerant. One of such sources is the resurrection plant. This is what we call in scientific languages Xerophyta viscosa. What it does is that this plant or this grass has the unique ability to dry itself to 5% relative water content. That is really dry. And when you add water to it, within 48 hours, it has revitalized itself to its normal physiological activities. That thing that makes it dry and don't die and gets back to its normal physiological condition is very critical for us, and that behavior is controlled in the genome by genes. And therefore, because we don't eat grass as human beings, we eat maize, we then go into that genome and try and identify that gene that is responsible for the drought tolerance. That is what we move from that grass to maize, and that is what we moved as well. We moved the promoters and then used other genes that will confer what we are calling delayed senescence. Senescence is when the plant or maize, for instance, loses the leaves when they sense that there is drought coming. The reason why the first thing it does is to lose the leaves is because leaves have stomata, and therefore that is the only source that water is leaving the plant. So you drop off that section that seems to be depriving you of that which is important. That's why the leaves actually drop off immediately. But when that happens, while it is strategic for the maize plant, it is not good for us as human beings, because you still require the same leaves to photosynthesize and give you the content in terms of the yields that you require. So that senescence or removal of the leaves needs to be slowed down, and that is what IPT gene does. It's called isopentyl transferase gene. That is what it does. And we have those transgenics here in the lab. It was done earlier by our former PhD students. I had an MSc student that was put into that and has now advanced it even further to a point of getting to know the stability of the gene, the nutritional content of that gene, and whether it has the tolerance that we claim. And all that is now positive. So what we are left to do is to go several seasons and get to know the stability of this, and then try and do more laboratory drought assays before now we release it out to the confined field trial after being approved by the National Biosafety Authority. So to the extent that this is contributing to food security, we strongly believe that this kind of research will actually lead to economic prosperity of our people, because food security is very critical. A hungry nation cannot work, and therefore the economics of those who are hungry is also deprived.
Chuo Kikuu cha Kenyatta kimekuwa kipaumbele katika masuala ya utafiti kuwezesha utoshelevu wa chakula nchini Kenya ili kuhakikisha teknolojia inasaidia kwa uzalishaji wa chakula kwa wingi.
As you have heard earlier from my colleague, this project is called Krismaban, and she told you what Krismaban is. The approach that I want to bring into Krismaban and to explain to you is, we took a gender approach in this project. And why a gender approach? Normally, scientific innovations, which are very good like this one, which bring economy to the people, which bring food to the people, and this was the purpose of this project, ends up reaching the end users. I heard severally my colleagues talk about farmers. But the issue here is, there are no people out there called farmers. Farmers are categorized in gendered categories of men and women, males or females, or boys and girls. And scientific innovations add to these people because eventually they are the ones who implement them. However, the adding is very different for both genders. In banana production, for instance, it has been tested and proved that bananas are traditionally a woman's crop. That is when they are grown for home consumption, and they are not grown for commercial. The minute tissue culture or commercialized bananas come into those so-called farmers, they introduce a commercial angle. And the commercial angle within the family changes the gender composition of within the value chain of banana production. We have already seen areas where new varieties come in, they raise the market value, they raise the food value, but unfortunately, the gender angle, the gender dynamics there within with the household changes the whole idea. How do they change? That's the question. Men take over because commercial production is normally done by men. The selling, the production, and this changes even the land acquisition, the land tenure, and every system. For example, men market bananas differently. Women market bananas differently. So what happens is that women become displaced from a production system that has always been associated with them. So the reason we brought the gender angle to this project was to make sure that we have gender responsive production. And that is where both men and women not only benefit from the new innovation, but they also benefit from the products that come out of the innovation. What we have been doing for the last 4 years is, as the process goes on, and I think you have been taken through the process from the laboratory all the way to the farm, now the farmers have literally grown these bananas in their own farms, we incorporated that gender angle, such that the people we have been working with, we have taken through a gender training process. We sensitize them about these dynamics that even sometimes cause violence within the family. Because you see, if a woman was earning something, or if she was able to produce the bananas, and then suddenly she's displaced from the farming system, the woman becomes degenerated, and therefore she has no money to give to her family. So what we have done is train those women and men together, sensitize them about these dynamics that causes violence with the family, and we find at the end of it all, we have people who receive the innovation in a more cohesive, gender integrated groups, gender responsive adoption, and we have done this throughout the banana value chain. That is from the growing, the farm preparation, the division of labor, where roles are shared, and also the marketing. One thing I would say is this: we have been telling the scientists, the breeders, everybody in the process of banana production, breed knowing that you are reaching men and women. These people have different breeding ideas. For example, very quickly, women may want a banana which produces faster, and that is not so big because they are not able to carry that to the market. You see these supports. Women may not access these supports because they don't own the trees within the farm. So we are advising the scientific breeders, breed with that in mind. Men, for example, may want a bigger banana because they will be able to ferry this to the market. It will fetch more money, but they will be able to ferry it with either the bicycle, the bodas, or some even own cars. They can also push the wheelbarrow.
Changamoto za mabadiliko katika karne hii yanakuja sana na kuharibu masuala mengi, hasa mfumo wa utoshelevu wa chakula. Hivyo ni muhimu sana kuja na uvumbuzi na utafiti ili kutatua matatizo haya. Kufikia hapo tumefika mwisho wa kipindi Boresha Kilimo. Hadi Jumamosi ijayo kwa makala mengine ya kilimo. Nimekuwa wako Laban Shaban. Wassalam.